In this video, we're going to go ahead and cover section 9.5, the binomial theorem. It's still part of unit 9, sequences, series, and probability. Let's go ahead and start with some definitions here. We have the binomial expansion. So a binomial, just in case you forgot, is a two-term term, so to speak. We have x plus y to some power. And for an expansion, what happens is we'll have this raised to some power. And, if you had, for example, if it was squared, you know that you're just going to FOIL. If it's cubed, you're going to multiply it 3 times and so forth. So the way it's going to end up looking is like the following. X plus y to the nth power is actually going to be x to this power and then y to the 0 power. And then you have your next integer, so n times x n minus 1, so basically 1 degree less than that, and this one goes up by 1. And it kind of continues that way all the way to the end. And I'm going to show you a little bit, something a little bit easier about this in just a bit. But where the coefficient of this term is basically the following: n factorial over n minus r factorial times r factorial, where n is your degree of the binomial, okay, and r is the coefficient that we're looking for. So let's just jump right into it. We have the following symbol. I like to say n choose r because it's going to lead into our next section on probability, but for now, we'll just look at it like NR. It's often used in place of this, so these two things mean the same. And we use these to find the binomial coefficients. So what this is going to do is it's going to give us the coefficient for this expansion, given these two numbers. Okay, so let's just jump right into it. We have example number 1. It says find each binomial coefficient. And I do apologize, I'm out of whiteout, so lots of scribbles, sorry. All we're going to do is we're going to plug this in. So this right here is n, this right here is r, and we just plug them into the formula like so. So remember, our formula is, just to kind of remind us, it's n factorial over n minus r factorial times r factorial. And we've dealt with factorials before, so this shouldn't be too bad, okay? So my top number is 11 factorial. On the bottom, I have 11 minus 5 factorial times r factorial, so times 5 factorial. Well, this is just equal to 11 factorial over 11 minus 5 is 6, so 6 factorial times 5 factorial. Let me kind of divide this here. And we know from past examples that this is going to be the same as 11 times 10 times 9 times 8 times 7 times 6 factorial. And I'm going to stop there because I have 6 factorial on the bottom. So let's get rid of that, okay? And then we're going to expand 5 factorial because I think I can probably reduce some of the numbers here. So we have 11 times 10 times 9 times 8 times 7 all over 5 factorial is going to be 5 times 4 times 3 times 2. And we can put the 1, but I'm not going to put it because anything times 1 is the same thing. From here, you'll notice that several things are going to reduce. We have 9 over 3 is just going to be 3 over 1, so 3. Okay. We have, let's see, 8 over 2 is just going to be 4. So we can reduce that as well. We can reduce the 10 and the 5, which 10 divided by 5 is 2. It looks like we can reduce further. We have this 4 now that goes away, is just a 1. So it looks like I'm left with 11 in the top times 2 times 3 times 7 all over, well, just 1. And let me multiply that really quickly. So I have, let's see, 11 times 2 times 3 is 6. 6 times 7 is 42. I'm not going to worry about the 1 anymore at this point. 11 times 42, let's see, it's going to be 2, 6, and 4. 462. Mental math, guys, mental math. There you go. There's the answer for the first one. Okay. Second one, letter B, we have the same thing, but just different notation. Remember that these two things mean the same thing. So this is the same as 9, 2, where this is n and this is r. Okay, same exact things. Let's go ahead and plug everything in. We have 9 factorial over 9 minus 2 factorial. Hopefully it's not too messy here. And then 2 factorial. What's that going to give us? Well, 9 factorial over 9 minus 2 is 7 factorial. 2 factorial is just 2 times 1, so I'm just going to put a 2 just to kind of save myself some steps here. And just like the one before, we can expand this to 9 times 8 times 7 factorial all over 7 factorial times 2. My 7 factorials are just a 1, so we're left with 9 times 8 over 2. 8 over 2 is 4. So 9 times 4 is just 36. And there we go. Easy, easy. Okay, let's look at another one. These are pretty simple, hopefully. Much simpler than our trigonometric units, which some of us did not like so much. Personally, I'm a fan. So let's go ahead and look at number 2. Same deal. We just have different numbers, so we're going to go right into it. Might just do 1 to save the time, but we'll see. So here we have, let's see, our n is going to be 7 and our r is going to be 5, and it's the same exact process. So we have 7 factorial over 7 minus 5 factorial times 5 factorial. And again, we're still looking for the binomial coefficient, so that's the same thing we did on the page before. Okay, so this is the same as 7 factorial, 7 minus 5 is 2 factorial times 5. And now I notice that this one's bigger, so I'm probably going to get rid of the 5 factorial. So 7 times 6 times 5 factorial. 2 factorial is the same as just 2 times 1, so I'm just going to put a 2 times 5 factorial. The 5 factorials are equal to 1. We have 7 times 6 over 2. 6 over 2 is 3. So we have 7 times 3 is 21. Very, very nice and easy. Yeah. Last one on this little topic here. Then we're going to move on to something a little bit more exciting. We have this is n and this is r. So to find the binomial coefficient, we are going to do the same thing. So 14 factorial over 14 minus 1 factorial. You can probably do this one in your head, but we're going to go through the steps just to kind of show you. Well, 14 factorial is just 14 times 13 factorial. The reason I'm doing that is because on the bottom, 14 minus 1 is 13 factorial. And I could put the 1, but 1 times 1 is just, it's 1. They're not going to change anything. So I'm going to leave it like this. So check this out. The answer is just 14. Very cool. And I actually left a whole bunch of space down here. So if you want to do the next part here, you can. But I recommend you kind of do the next part together because we have something kind of new here. Yeah. We have this thing called Pascal's triangle named after some guy, Pascal. I'm not going to go too much into history here, but check this out. The way it works is you start with a 1, okay? And this is actually considered row 0. So it's like your 0th, is that a word? 0th row, okay? The second row, which is actually it's actually going to be our first row. And I'll show you why in just a bit, okay? This triangle is very handy when it comes to binomial expansions because what we do is we actually take these numbers, and I'll show you how to construct them in just a bit. We take these numbers and they become the coefficients for each of the terms in the binomial expansion. So instead of having to multiply x plus y times x plus y times x plus y, n times, you can just figure out which row it falls under, and these coefficients will be the coefficients that go in front of each of those terms, which I'm going to show you how to do in just a bit. So let's see how the triangle works. 0th row is just a 1. First row is 2 1s. The second row, which is right here, and I probably should have made this a little bit neater, but the second row, this one, is basically going to be more 1s. So you'll notice that there's 1s on each side of the pyramid or triangle. And then these two together give me 2. So that's how you get the middle term. You just add these two together and that gives you 2. For the third row, well, we end with the 1s again, but now we're going to be adding those two numbers. So 1 plus 2 is 3, 2 plus 1 is 3, and there's my 1. Fourth row, well, we end with the 1s again, and now we're doing 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, and there's my 1. So you'll notice this pattern just kind of continues. 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5. And you will also notice that the numbers kind of repeat on each side as well. And that makes sense because, well, it's a binomial expansion. If you're multiplying it this many times, you're going to have it twice in some point, right? Same with the middle terms, okay? And yeah, the pattern just continues. So this would be the 5th row. I'm going to label whatever I have here. This would be the 6th row. This is the 7th. This is the 8th. And this is the 9th. And of course, it continues. You can continue this on and on and on and on. That's why I have the dots right here. But for reference, I do recommend you copy at least up to here. Um, because for some of the problems you're going to have, you are going to be asked specifically to look at a certain row. So instead of having to construct the whole triangle all over again, you can just kind of use this as reference, okay? So let's see how this applies to binomial expansion as per this triangle. Here is some more stuff, okay? So you noticed on the first page of this set of notes, we had some notation where you had kind of like the first term to the nth power, and the second term was to the 0 power, which wasn't even shown. But here's how this works, okay? So let's say we have our binomial x plus y to the 0 power. Well, anything to the 0 power is equal to 1, and that's why that very first part of the triangle is just a 1. So you'll notice here, and I'm going to just make like a mini one. This is row 0, starts with a 1, because anything to the 0 power is equal to 1. Row 0, okay? Row 1 is the binomial to the first power. So remember the second, or I guess you'd say the first row, has a 1 and a 1. So we have our coefficients of a 1 and 1. And what you do is you take each of these terms, you just plug them in. So 1x, 1y. Easy as that, okay? The way, another way to think about this is you would take the second term, so y, and you can think of it like this, y to the 0 power, and over here you have x to the 0 power. So while the x has a little 1 here, the y would have a 0. Over here, the y has a 1 and the x has a 0. So the first term will start descending powers this way. So the first term, and this is kind of extra here, you don't have to write this. The first term descends this way in powers. I guess I can put powers descending. And then the second term, I probably should have wrote this down somewhere. The second term will go this way, okay? So you'll notice that on the next row, row 2, we have our coefficients. Remember, the next coefficients are 1, 2, 1. So 1, 2, 1 are right there. And you have x starting with the power of 2. So x to the power of 2, x to the power of 1. And right here, well, there is none because x to the power of 0 is just 1. So we don't really have to write it, okay? And if you look at the y's, here you have that imaginary y to the 0, which again is equal to 1, so that's why we don't write it. Here we have 1, y to the first power, and y to the second power. So you'll notice that the second term descends the other way, or I guess you could say ascends this way, but however you want to think about it. But you have 2, 1, 0. The x's, 2, 1, 0. So they kind of go backwards of each other, yeah? Row 3, same deal. Now we have to the third power, so you'll notice the coefficients are now going to be 1, I'm out of space, 1, 3, 3, 1. And this is just the pyramid from up here, okay? I'm just kind of making a mini one. So we have 1, 3, 3, 1. So 1, 3, 3, 1, okay? My x's are going down, so 3, 2, 1. Remember 0, x to the 0 power. We don't really have to write it because, well, it's just equal to 1, but it's there, okay? And the y's go the other way, so 3, 2, 1. And again, my y to the 0 is right here. Don't really have to write it because it's just equal to 1. And the same thing applies. So row 5, row 4, I'm sorry, row 4, row 5, you have the same thing. Your coefficients 1, 4, 6, 4, 1, which are coming from the pyramid. And then your x is going down to 4, 3, 2, 1, 0. Y is going down the other way, 4, 3, 2, 1, 0. And the same for the 5, row 5. Pretty cool. Let's look at an example of how to use this. Actually, these ones are worked out for us because of the time. I don't want to spend too much time. So for this first one, let me kind of cover some things here. It's my calculator. We have used the 8th row of Pascal's triangle to find the binomial coefficients, and then we have our weird looking notation. So this is what we had in the way beginning. Binomial coefficients basically means well, we're going to use the 8th row to get the 9th row basically. So what I did for the solution for this is say, well, since we have the 9th row here, we're going to look for I'm sorry, since we have this notation here with a 9 being our first number, that means we're looking for the ninth row. So we have to use the eighth row to get the ninth row because you need to add them up, right? So here is the eighth row, and I just copied this from the page before, so you don't have to memorize it or anything. But it's 1, 8, 28, 56, 70, 56, 28, 8, and 1. And to get the ninth row, all we have to do is write down the numbers. So we start with the 1 over here, and then 1 plus 8 is 9. This plus this is 36, 28 plus 56 is 84, and so forth. And basically, you just add the numbers, the consecutive numbers, to get the next row. And you will notice that we also end with our ones on each end to kind of complete the triangle. And that's it. These are going to be our binomial coefficients per term. So if I were to actually expand whatever this is equal to, this is the way the numbers would come out. Okay. And that is it. That is it for that third example. Let's look at the next one. I believe it's a similar problem. It says write the expansion of the expression. So in this one, we're actually going to write out what this would look like using Pascal's triangle. So how do we do that? Well, here's the solution. Since it's to the fourth power, we're going to use row 4 of Pascal's triangle. And row 4 is basically 1, 4, 6, 4, 1. So the first term is going to have a 1. The second term is going to multiply by 4. Third term multiplied by 6, fourth term by 4, and the last one by 1. So here's how it works. Okay, and I did label all the zeros just so you can kind of see how the ascending and descending work. So you have the first term is an x, okay? My first term is an x. So notice that all of my x's are going descending order on the degree this way. So the first term has x to the fourth, x to the third, second term x squared, fourth term x to the first power, fifth term x to the 0 power, okay? And then my second term, 2, is being raised to the powers as well, but it's going the other way. So 2 to the fourth is over here, 2 to the third, 2 squared, 2 to the first, 2 to the 0. Patterns, guys, patterns. Um, and you will also notice the coefficients are in front of each one. So we have our 1 here in the beginning. So there's the 1. We have 4 following next. So there's 4. There's a 6 in the third spot. So there's 6, 4, 4, and then 1, 1. And these are not the final coefficients. They're coefficients that are being multiplied times that term. So just please keep that in mind, okay? Let's look at the final outcome here. And I did kind of go step by step. I said, well, I know 2 to the 0 is just equal to 1. 2 to the first is just 2. 2 to the second power is 4. 2 to the third is 8. And 2 to the fourth is 16. So in my last step, all I did is I kind of combined like terms. So the first one is just going to be, well, x to the fourth, because anything times 1 is the same thing. 4 times 2 is 8. 6 times 4 is 24. 4 times 8 is 32, and that one just stays the same. And we are done. Lots of smiley faces today because we haven't drawn too many smiley faces this week. And that's it. That is how you expand one of these binomials, okay, using Pascal's triangle. Let's go ahead and do a few more. And by the way, I think I'm going to just do one more of this kind here, so we can just do the rest in class, just for the practice. So here we have, write the expansion of the expressions. There should be expressions. There's 2 of them. We put that here. Grammar is important too, guys. The following: a 2x minus 3 to the fourth and x minus 2y to the fourth. I think we're going to do this one in class. So if you want, make a note here for yourself. We'll do the second one in class. Let's do letter A right here. So notice that we have a degree of 4. So since we have degree 4, we're going to use row 4 of Pascal's triangle. And just because I can, I'm gonna do a little mini one here. It's good practice. So row 0 is 1, 1. Then we have, I'm sorry, row 0 is 1. Row 1 is 1, 1. Row 2 is gonna be 1, 2, 1. Row 3 is 1, 3, 3, 1. And row 4 is 1, 4, 6, 4, 1. So this is the one I'm actually gonna be looking at. Remember that the first row is actually row 0. So please keep that in mind, okay? So we're gonna use this one. So 1, 4, 6, 4, 1 are my coefficients that are going to be multiplied times the terms. And then also, just so we know, our first term is 2x, so it's this one, And our second term is 3. Okay, so those are the ones we're going to be raising to the power and all that. Let's begin. For the first, I guess, term here, we have 1 times 2x to the 4th power. You always start with the degree that we started with, so 4th power. And then our second term, 3, is to the 0 power, because you start backwards on that one. Plus 4, so that's my next coefficient. Let's see. Oh, I forgot one thing. We got to put that in parentheses because 2x is the whole term, right? So 2x to the 4th power. So for the next one, we have 4 times 2x to the 3rd power, because that's, 3 comes before 4, times 3 to the 1st power. So we're going down this way for 2x, and we're going up this way for the 3. Plus 6 is the next coefficient. 2x, what's before 3? Well, 2. So 2x squared times 3 squared. So in this one, they're both the same because, well, it kind of overlaps, right? Plus 4 is the next coefficient. I'm almost out of room here. 2x to the 1st power. So we're just descending 4, 3, 2, 1. And then we're ascending with the 3. So 3 to the 3rd power. And I should have made this a little bit more that way. Last one is going to be that 1. So 1. And then we have 2x to the 0 power because that's what comes before 1. And then, I'm out of space, 3 to the 4th power. So hopefully you can see that. That's a 4 there. Horrible, but yeah, that's together. I'll move it over just a little bit right now. And yeah, so you'll notice that all of my 2x's are going descending order 4, 3, 2, 1, 0. And my y's, I'm sorry, not my y's, my second term, which is 3, is descending the other way. So we have 4, 3, 2, 1, 0. Or you can think of it as ascending this way from left to right. Okay, so let's rewrite this now. I'm going to write this a little bit nicer, move it more over this way so it helps fits. So let's move it over here. 1 times anything is just 1. This is just 1. So here I just have 2x to the 4th power. And we'll reduce it right now. We're gonna go a little step by step here. Plus the next one we have 4 times 3, because 3 to the 1st power is just 3. So 4 times 3 is going to be 12. And again, 2x to the 3rd power. I'll reduce those right now. Plus, so now this is this one. This one right here, we have 6 times, I'm doing 3 square. 3 square is 3 times 3, which is 9. 9 times 6 is 54. Okay, so 9 times 6 is 54, so it's going to be plus 54 times 2x squared. And again, I'm going to deal with this part after because I don't want to confuse anything up to that point. So there's that one. And then this one we have, let's see, 4 times 3 cubed. 3 cubed is 3 times 3 times 3, which is 27. 4 times 27, I'm thinking 2 times 27 is 54. Double that is 108. So I have 108 times 2x to the 1st power. And then last but not least, we have 1 times 2x to the 0 times 3 to the 4th. So this part right here is just going to be a 1. So I'm not even going to worry about it. 3 to the 4th is 3 times 3 times 3 times 3, which is the same as 9 times 9, which is 81. Okay? See, no calculator required so far. All right, let's keep reducing. So now we kind of have our coefficients, but you'll notice that we have some stuff raised to the power. So from here, I'm going to go ahead and do 2 to the 4th power. 2 to the 4th power is 16, and then we just have our x to the 4th. So that first one is done. Here we have plus 12 times 2 to the 3rd power is 8. So 8 x cubed. And again, we'll simplify that in just a bit. Plus 54. 2 to the 2nd power is 4. So times 4 x squared. This one I'm going to go ahead and multiply right off the bat because I know that anything to the 1st power is the same thing. So 108 times 2 is going to be 216x with the x there, and then plus 81. Oh, why did I put 18? Gotta get me some whiteout. Plus 81. Okay. All right, we're almost done. Last thing here. So this first one is done. 16x to the 4th. 12 times 8 is 96. So 96x to the 3rd power plus 54 times 4. Again, I'm going to double it. which is 108. Double that one is 216 x squared. This one is already done, and the last one is done. And we are done with our binomial expansion. So in other words, if you had multiplied this right here 4 times, so 2x minus 3 times 2x minus 3 times 2x minus 3 times the other one, 2x minus 3, you would have gotten this. And I know it might seem like, well, this is kind of a lot of work too, but once you get really good at this, at this, it's actually it's faster. It's a little bit faster. Okay, so we're done with that one. We'll do letter B in class if you want to just kind of leave some room here at the bottom. Okay, let's go ahead and jump to last example. I think we have 2 more. Actually, we're going to just do 1 more again because of the time. And these are not too bad. It's just, I don't want to spend 40 minutes on this. So number 6, write the expansion of 5 plus y squared to the 3rd power. This one I like because it has a power inside, which means we're going to have to keep track of that as well. Okay, so notice that this is row 3. Okay, so just real quickly, number 1, 1, 1, 1, 2, 1. Let's see, that's row 0. That's row 1. That's row 2. So we need one more. 1, 3, 3, 1. So row 3. So we're going to use these numbers. Okay, so I'm going to write them out. So 1, 3, 3, 1. I'm going to space them out a little bit better this time, unlike the one before. And then just like last time, my first term is the 5. And my second term is y squared. So be careful with that square, okay? Let's begin. For the first term, we're going to have a 1 because that's the first coefficient. So 1 times 5 to the 3rd power, because that is the leading degree here, times y squared to the 0 power, because we have to go backwards with the second term, plus 3, there's my coefficient, 5 squared, we're descending, okay, times y squared to the 1st power. So again, be careful here because I know there's a power here, but we still have to raise that power to whatever degree it falls under in its place here, okay? Next one, plus another 3, and now we have 5 to the 1st power, and then our second term y squared to the 2nd power, okay? And last but not least, 1 times, well, 5 to the 0 power times y squared to the 3rd power. Just to kind of hit home what we did here, okay? Notice that all of my y squares are there, but now they're raised to the power of 3, 2, 1, and then 0, okay? The other ones I'm not going to highlight because the 5 it's a little more easy. It's easier to see. 3, 2, 1, 0. But this one I do want to highlight because, again, you already have a power, so don't get confused. Whatever this term is, copy it down. If you want, write it down 4 times and then just put the powers if you want to do it that way. Okay, so let's go ahead and work this out. We have 1 times anything that's the same thing, so I'm going to go ahead and multiply this here. 5 cubed is 5 times 5 times 5, which is 125. Y squared to the 0 power is just 1, so I'm not even going to worry about that. Plus, here we have 3 times 5 squared. 5 squared is 5 times 5, which is 25, and 25 times 3 is 75. Y squared to the 1st power, nice and easy, is just y squared, so no extra work required there. Plus, here we have 3 times 5 to the 1st power. Anything to the 1st power is the same number or term that we started with, so 3 times 5 is just going to be 15. And when we're multiplying powers, you just distribute, so 2 times 2 is 4, so y to the 4th power, okay? Did I skip one? No, we're good, we're good. And the last one over here is going to be, so 5 to the 0 is just 1. Again, we distribute here, so 2 times 3 is 6, so y to the 6th power. And I believe that that is it for this problem. So let's go ahead and box it up. And we are done, believe it or not. Okay, so again, this is not too difficult. Let me just check one thing here real quick, see if I want to do that last problem or not. I don't know if we're going to have time for it. The last one's a little bit, here you can kind of see it. Let me show it to you. Go ahead and copy it down real quick. So this one's not that bad either, but you'll notice that it goes all the way to 11. So it might take us a little bit of time. I think we're going to do that one in class, if that's okay with you guys. As always, if you have any questions, please just let me know. And thanks for watching.